In this video, we're going to be looking at factoring with the GCF, which is the greatest common factor. So some things to know before you start this lesson is you should first understand the distributive property, and then you should know these two rules for exponents. If you multiply exponentials together, you add the exponents, and if you divide them, you subtract. All right, so those are just two helpful things to know before you start factoring. All right, so what does factoring mean? All right, we learned about the distributive property already. All right, so when we distribute this in, so going with this equal sign going this way, when we take this A and multiply both, that's called distribution, or using the distributive property. When we go the other way, now we're taking this A and we're kind of pulling it out and leaving behind the B plus C. This is known as factoring. So distribution is kind of bringing things together, and factoring is separating them out. So another way to think about factoring is if you look at a number, you can factor it down into its smallest pieces. For instance, 30 is 3 times 10, and then 10 is 5 times 2. So you might have done these number pyramids before, but 30 can be broken down into these component parts of just 2, 3, and 5. And we're going to do the same thing with expressions. That's basically what algebra is, just taking stuff we used to do with just numbers and doing it with x's. All right, so we just want to do this with expressions. And we're going to start off by doing that with the greatest common factor, which I'll just put GCF because it's the shorthand. And it's the largest term that will evenly divide all the terms in your expression. So if there's 4 terms, it has to divide all 4. If there's 3, it has to divide all 3. All right, when factoring the GCF is the largest thing that we can factor out. So like AB plus AC. A is that thing that is a factor of both of those, and that's what we pull out to the front. All right, so find the GCF and then factor 5x plus 10. So we're just basically asking ourselves, what would divide both of these terms? So the first thing is, I always kind of do it in 2 separate pieces. I do it with the numbers, and then I do it with the variables. So with the numbers, what number divides 5 and 10? The answer is 5. And then with the variables, what variable expression would divide x and nothing? Well, there's no x in that second term, so there's nothing to divide, so there's nothing. All right, so what is this going to turn my expression into? If I take this 5 and pull it out, all right, and it's becoming that 5 there, there's just an x left over. 10, and when you're factoring out, you're thinking about dividing it out. So if I'm dividing it out, 10 divided by 5 is 2. Another way to think about it is 10 is 5 times 2, and that 5 is coming out, and you're leaving behind the 2. All right, one way to check your answer is just distribute this back in, and make sure you get back to what you start with, and then we do. All right, so here's another one. Find the GCF and then factor. So again, I always start off with the numbers first. There's a 3, and there's the kind of invisible 1 that we don't write in front of the x cubed. What number divides 3 and 1? The only thing is 1. All right, and then the variables, I have x squared and x cubed. What's the biggest thing that they have in common? Well, this is 2 x's. 2 copies of x. This is 3 copies of x. The biggest thing that they both share is 2 copies of x. All right, so I'm pulling out a 1x squared. All right, 3 divided by 1 is still 3, so it doesn't change that number. But I've gotten rid of all the x squared, so it's completely gone. All right, 1 divided by 1 is still 1. Again, you don't have to write the 1. And I've gotten rid of 2 copies of x, so there's 1 copy left. Again, I'm kind of doing this, taking that x cubed and I'm dividing out x squared. That gives me x to the first. All right, so the way this would normally be written, normally you wouldn't write that 1 at the start, and that would be your final answer. All right, here's one for you to try on your own. I find the GCF and factor this expression. All right, I'll show you the answer in 3, 2, 1, and the answer is 4 times 2x plus 1. All right, 4 divides 8 and 4. And there's no x term in all the terms, in both the terms. All right, so you can't pull out an x. All right, so now we're just going to make the problems a little bit more involved. There's going to be more terms and more variables, but you can still just do it piece by piece. So I first start with the numbers. There's 3, 9, and 6. All right, what number divides all 3 of those? And again, I'm looking for the biggest number that divides all 3 of those, and in this case, it happens to be 3. I have x squared, x cubed, and x to the 4th. I just basically look at the biggest exponent, or sorry, the smallest exponent that they all share. In that case, it's 2. And then y cubed, y squared, and y squared. All right, the smallest exponent they all share is y squared. All right, now I got a c. So that's the greatest common factor. So that's been kind of pulled out of all these, divided out to the front. And what's left over? Well, in the first term, the 3 is gone, the x squared's gone, and 2 of the y's are gone, so there's a single y left. In the second term, 9 divided by 3 is 3. I get rid of 2 of the x's, but there's 3, so there's 1 x left over. And I've gotten rid of all the y's. The last term, 6 divided by 3 is 2. X to the fourth, I divided by x squared, so there's still 2 copies of x left. And I've gotten rid of the y squared, so that's my final answer. All right, another example, but nothing's going to change. All right, so I'm just going to kind of go through each piece and figure out the biggest thing they have in common. So with these 3 terms, what number divides 12, 6, and 9? The biggest number that divides all 3 is 3. A to the fourth, a to the fifth, and a squared, with the most a's they all have in common. The most they have is the 2a's, which is the smallest exponent there. B cubed, b squared, b cubed. The most b's that they have in common is the smallest exponent, 2, b squared. All right, so that's the greatest common factor that I've pulled out of all these. And what's going to be left behind? 12 divided by 3 is 4. I have 4 a's, I'm getting rid of 2, so there's 2 left over. I had 3 b's, I'm getting rid of 2, there's 1 left over. I had 6 divided by 3 is 2. I'm getting rid of 2 a's, so there's 3 left over. And I got rid of both of the b's that were there. And then 9 divided by 3 is 3. I got rid of both a's. There's 3 b's, I'm getting rid of 2, there's 1 left over. All right, so just kind of thinking about what do these all have in common? That's what's going to go in the front. And then just whatever's left over is still going to be in the parentheses. All right, so here's one for you to try on your own. I find the GCF and factor this expression. And I'll show you the answer in 3, 2, 1. And here's the answer. So the greatest common factor, they all are divisible by 2. They all share an m, and they all share 3 p. So 2m p cubed is the greatest common factor, and everything in parentheses is what's left over. All right, so go ahead and practice using the GCF. All right, make sure you have a firm grasp of using it and factoring things out, and how this expression, that's one expression, kind of turns into 2 with parentheses. All right, because factoring GCF is kind of the basics for a lot of other types of factoring.